Okay, so we're going to be going over lesson 5.5, transformation of logarithms. And I just realized that that's not right. That should say transformation of logarithms right here, not solving systems. All right, cool. Fix that problem. So 5.5. All right, so let's go to the packet. Okay, so you're going to be sketching some graphs on these first two problems, and we're looking at how logs transform. So if you remember in the last homework packet, we were looking at different transformations of different functions. We're going to be looking mainly at logs in this first part of the packet. Okay, so what I went ahead and did is wrote down kind of the graphing form of a log. And those same values that we talked about, the A, the H, and the K, those are all here in the log as well. Okay, so here it says sketch the graph. All right, so to sketch this graph, let's kind of take a look at what a parent function of log even looks like. Okay, so log of x, that's the parent function. Okay, and what it looks like, and actually let's just go to Desmos and take a quick look at it. Here's a base log function. Now that little number at the bottom, that right here, if it's not written, it's automatically 10. So if I turn that on, here's what log looks like. Just log of x. And if you notice, if I erase the 10, it ends up being the exact same graph. So if there's no number there, again, it's just a 10. Okay, so I'm going to go back just so I keep my 10 there. All right, so that's what it looks like. And you notice here it has this 0.10. All right, so it goes to the 0.10, and there's actually an asymptote. So it doesn't go through this line, the y-axis, because they're at x equals 0, there is an asymptote. But basically never will, x cannot equal 0. So it comes up through here, and then it kind of just veers off to the right here. Almost looks a little bit like the hyperbolas from the reciprocal functions, how it kind of comes down, or the exponential ones where it gets really close to the line here. All right, so what we're going to be looking at is what will these numbers cause that to do. All right, so this, you guys remember, that's a vertical stretch by a factor of 2. This is going to move it not to the right, but to the left 2. And this will go up 3. Okay, so if I'm focusing in on this point and the asymptote comes from that value right there, because basically this whole thing cannot equal 0. So -2 is the asymptote. So if that's +3, the asymptote, remember that, is at -2. So I can just draw that asymptote, which I couldn't before because it was right on the y-axis. And then that point right here at 1, 1, 0, it's going to move left 2 and up 3. So it's going to go from here, 1, 2, and then it's going to go up 3. So that little point that crossed the x-axis, it'll move up there. And now it's also going to stretch going up. Okay, so it kind of flattens itself out going this way. And what it does is that when it gets to 1, actually, let's just take a look real quick. You'll notice here as I kind of drag along here, the y value, as it gets really close, once it gets to 10, it actually becomes 10.1, or becomes 1. So that's 10, it isn't on our graph. So we're going to kind of do our best to make sure we stay under the y value of 1 as we go to the right. Okay, so normally that would mean that if the graph was down here, we would stay under that line. We'd only go 1 unit up above where it crossed the x-axis. So over here, I would normally go kind of here. I would stay right below the 4 because we went up a little bit. But now I've got a vertical stretch of 2. So that means that this is going to increase and double in height. So it's going to kind of go like here. Now, again, guys, if you guys are doing this, you're sketching this. This doesn't have to be super perfect. I think the main factor is to see that it's going to the left 2 and then up 3, and then just make it a little bit higher than it normally would be. But, we're not going for perfection here, okay? So you would do that with your function here. Okay, now in this one thing I need you to realize is that there are like tons of different log functions. So log of base 3 is a parent function in itself. So the parent function for this one is log base 3. Whereas the parent function for that one was log base 10. So there's different parent functions depending on what your base is, okay? And you'll see how that compares to the exponential one later. So sketch the graph and describe how the graph is transformed. All right, well, we can just look at the graph here, and we know that this transformation will cause it to shift. It will go to the left 3. So remember the parent function. Let's take a look at the parent function of what log base 3 looks like. So log base 3, that's right here. So you can see it also passes through 1, 0. The only difference now is that look as I drag along here. Remember the last one was log base 10, and it didn't get to 1 until I got over to x equals 10. But here, see if I can get it to drag in. Oh, there we go. It gets to 1 at 3, or once it gets to 3, y equals finally equals 1. So it reaches that 1 a little bit sooner. Okay, so on this graph, let's say I was doing the parent function, it would go through 1, and it would get to 3 here, right? But those points are going to shift now. Now they're going to shift left 3. So go 1, 2, 3, and then 1, 2, 3. All right, and then also remember that the asymptote is going to be at x equals negative 3. So we make it asymptote going up and down there. Okay, and then we just kind of do our best to kind of ride along this line and then start to move this way and just, it's a sketch, guys. So just do your best. Make sure it's going that way, okay? All right, so the main thing is like figure out like where at least one of those points are, like that one that crosses the x-axis. So all of these logs, they all parent functions have a point at 1, 0. So no matter what the base is, that point will always be at 1, 0. And the original asymptote is always right there on the y-axis. So you just got to shift that over based on the transformation. Okay, so now the next one. Okay, shift the graph log of x up 3 units, and we're going to do down 4 units and then left 5 units, and then graph both the original and the transform function on the same set of axes. Okay, so let's first start with the parent function y equals log base 10. Remember, there's no base there, it's a 10. So we know that there's the asymptote going right through the y-axis. It's going to go through this point 1. Remember what I told you, kind of like it doesn't get up to this value of 1 until it gets to 10. So it kind of just goes off in the direction that way. So that's a log base 10. All right, so we're going to look at this graph and shift it down 4 and then left 5. So let's focus on the asymptote first, which that is vertical, so it's only going to move left or right. So that is going to shift left 5 units. We'll go over here to negative 5. That will be the new asymptote. The point that will shift down is that point that crosses to the x-axis, the x-intercept. Okay, so that one is going to go left 5 to here, and then down 4 units to here. So remember that from the x-axis, it kind of went up and got really close to the 1, but didn't quite get there until it got over here somewhere. So I'm going to kind of start from the line here, go up through this point, and then it should be 10 units away to where it starts to actually, where it gets to the next line up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right there. But again, guys, not looking for perfection. You just need to really show that it's that shift. So this is log, we'll say log x, and then this is the transformation. So this is, we'll actually just say f prime. Okay, f prime at x. I don't know if you guys remember prime from IM1. It's whenever you make one transformation, then that's the prime. Second transformation, double prime. All right, so anyways, at right is a graph of log base b of x. So we're going to do this one together, so you guys don't have to do your own problem here. We're just going to kind of walk through this together, so because I'm going to show you guys what this is all about. So basically, we need to look at what happens when b changes. What is the difference in these different functions when b is a different value? And notice how all of these kind of like start from the bottom here and come up and go to the right, whereas this one is kind of flipped upside down and it goes this way. Now, normally you would say, okay, well, it's the same thing flipped upside down because it still goes through 1 through 1, 0, right? So we'd say that's a reflection. So all we do is we put a negative in front. But that's not what we're changing. We're not changing a negative in the front. We're changing b. So what does b have to be in order for this to flip? So that's what we have to figure out here. Okay, so let's take a look at some graphs here. All right, so I'm going to mess with, let me turn this one off. And I got this one down here that I'm going to kind of mess around with. All right, so let me move this up here a little bit here. So what I'm going to do with this is let's just change the base around. So first we're starting with 2, okay? Then let's make it 5. Okay, that didn't do anything. Except it looks like it kind of compressed a little bit. So 10. And you can see it's shrinking down. It's like compressing more. Okay, and as I do that, I'm like, let's go to 100. It just keeps shrinking. Let's go to 1,000. You see, it just keeps shrinking, right? So it's not really flipping. I want it to flip. Well, maybe if I make it negative, it'll flip. So let's try a negative number, -2. Oh, there's nothing there. So that must mean that negative is, you can't use negative numbers as a base. Okay, well, I can't do that. So let's try 1. Nope, doesn't like 1 either. 0? Mm-mm. How about like 1.2? No, I mean, that kind of stretched it, but it's still kind of going up and to the right. I want it to flip. I want it to go the other way. Let's try like less than 1. Ah, so it flipped there. Okay, but remember, negative numbers didn't work. Okay, let's go to like 0.9. Okay, it's still flipped. Let's go to a little more than 1. Ah, so now it goes back to the other way. So as soon as it went below 1, it flipped. So let's go down to like 0.1. Oh, it's still flipped at 0.1. But as soon as I go to 0, it doesn't exist anymore. If I do a negative number, it doesn't exist. So in other words, it has to be bigger than 0, but less than 1. So that's the trick here to make this thing flip, is your b value has got to be less than 1. B value has to be less than 1, but also greater than 0. Can't be equal to 1, also can't be equal to 0, so I don't put like the equal to sign down here. So it has to be between the two. So some possible b values would be like the ones we wrote, or that we did, 0.1, 0.3, 0.999. Okay, as long as it's less than 1, it flipped. Okay, so that's interesting. It's actually new to me. I didn't know that. All right, so let's take a look up here. All right, so make a table, then graph this function log base 3 of x. All right, so what we're going to do is we're going to make a table, all right? Because that's what it tells us to do. And in our table, we're going to use the points. Let's go 1, 2, 3, and 4. Okay? And the reason I didn't use 0, if you remember, the parent function of these x at x equals 0, it's an asymptote, so it's not even a part of the domain. So I have to use numbers bigger than 0. So I'm using these. All right, so to find out the values for that, if I plug in those numbers for these functions, I am going to use Desmos. The way I'm going to do that is I need to create a table, and if you guys remember from the last lesson, I did this where I used Desmos, the table, to fill in the values for me. What I need is I need to type the function up here. Okay, so if you just list out your inputs, the ones you want right here, and then put the function here. So to do that, I'm going to move my head out of the way. Click functions here at the bottom in the toolbar, and then click this one, the log base A. Okay, so now I want that same base of 3, which is the one I'm doing, of x. I got to put the x inside the parentheses. And if you remember, these x's have to match, so I have to put a little 1 after it. So just type a 1 and it automatically pops up. Now, what I did is I did like a dashed line here just so you guys could see the pattern of what's happening here. So you can see that kind of log pattern. And then we're going to write down these values here. So in my table, I'm going to write down 1, 0, 2, and let's round that to 0.6, and then 3, 1. And then for 4, we'll put, I'm going to round it to the nearest tenth, so that'll be 1.3. Okay, so that's what I've got for log base 3. All right, so I want to graph that basically on over here. Let's make a table and graph it. So now remember, the asymptote is going to be x equals 0 for all these log functions, unless you change the h value. Okay, so we have 1, 0, still goes through that point. 2.6, right there. 3 and 1, and 4 and 1.3. So about there. Okay, and so this kind of goes off in this direction, and then gets really close to the y-axis, but doesn't quite touch. Okay, now this one. All right, so your answer to the previous problem, use your answer to the previous problem. So use this to graph this function. Okay, so we're using this. So basically, it's going to be the same function or the same base function, but now it's been transformed. So we're going to use kind of the information we got up here to be able to figure out what does it look like after we do these transformations. Now, first of all, by the way, guys, cross this out. There's an error. I think when we were typing up these packets, that kind of popped in there on accident. So just focus on this part. Now, what I'm going to do is I'm going to rewrite this so it's kind of a little bit more familiar to you, because you might be like, well, this doesn't look familiar. It's the same thing as writing log base 3 of x plus 4, and then just putting the plus 2 on this side. So maybe that helps your brain kind of see what's going on, is that kind of vertical change or the shift up and down is right here. They just put it in the front of the function instead of in the back of it. Okay, so what does that mean? That means that our function, log base 3 of x, is going to go to the left. It's going to shift left 4 units, and then it's going to go up 2 units. So what I'm going to do is I'm going to go to my table and use that to help me shift all these points. But first, let's write out the asymptote, because now the asymptote, which comes from that number inside, is going to be x equals -4. So let's draw that up. So here's the asymptote now at -4. And our table now, but I'm going to write it kind of side by side so you guys can see that. So I'm going to repeat that down here. 2.06 or 0.6, 3, 1, and 4, 1, 3. Oops, 1.3 there. Okay. Okay, so I'm going to move all the x values left 4. In other words, they're going to decrease by 4. So all these x values, I'm going to just basically take away 4 from them. So 1 minus 4 is -3, 2 minus 4 is -2, then -1. Oh, yes, -1 and 0. Okay, and then the y values, because remember the left and right shift is changing x values, and the up and down shift is changing y. All these are going to add by 2. So I'm going to go, that's going to go from 0 to 2. Plus 2 is 2.6. That will move to 3. And then this will go to 2 plus 2, so that'd be 3.3. Okay, so I'll just graph my new points. So now and you remember I'm using this one. So now -3 and +2, -2 and -2.6, about right there, -1, 3, and then 0, 3.3, so about right there. And remember, it kind of curves in this direction like that, goes off there, and then it kind of comes back down, gets really close to the asymptote there, okay? Now, given this system of equations, solve them algebraically. So we're going to do this on paper instead of like graphing them. You know, you could graph these and just confirm your answer, but we're going to do it algebraically. Now, what I notice is that these are both set equal to y, so that means I can just set the equations equal to each other. So let's do 4x equals x squared plus 13. All right, now quadratic x squared, automatically I'm thinking I gotta make everything equal to 0. So let's remove this 4x from this side and subtract it from both sides. Okay, so now this is 0 equals x squared, and we want to do the terms in order or standard form. So x squared, then the x term, so minus 4x, and then plus 13. And now I want to try to solve this. So let's try the x. Let's try to factor it first. So a times c, 13x squared. Some of you guys already might see a problem here. Now I look for those two numbers. What multiplies 13 adds up to -4. Nothing works. So I can't factor it. So I got a couple options here. Quadratic formula is probably the first thing that pops in your mind. There is another way. Okay, I will show you the quadratic formula, but I'm going to show you completing the square, which you guys know how to do because you have changed equations like this into graphing form. All right, so let's complete the square. Okay, so remember with quadratics, you're going to separate your x values. You're going to add the completed square, and then you're going to keep this value out here, and then you're going to add it here and subtract it here, that value. So if I complete the square, remember it's going to be your b, which is the -4, divided by 2, and then you square it. So -4 divided by 2 is 2. 2 squared, 4. So I'm going to add 4 and subtract 4 at the same time. All right, now I'm going to factor this out. And if I factor this out using the x, remember here I would just use the x. I put the 4x squared on top, -4x on the bottom. What two numbers multiply to 4 but add up to -4x? That'd be -2x and -2x. So that means that this is x minus 2 and x minus 2. And 13 minus 4, that would be 9. Okay. All right, let's move this on over here. So that means that 0 is equal to x minus 2 squared, because they're the same, plus 9. All right. So that's graphing form, but that doesn't really help us solve for x, right? So what we're doing now is I'm going to subtract 9 from here. Okay. And normally what I do here with this type of equation is we'd square root both sides, because that cancels out the square. So now I have just x minus 2. The only problem here is I can't take the square root of a negative number. So what does that mean? That means there is no real solution. Now, does that mean there's no solution at all? No, not necessarily. But in this case, there's no real solution. So I'm going to continue this problem further, but that's really all you would need to do, is say there's no real solution. Okay, now, if you do the square root of a negative number, remember that you are just doing an imaginary number. So the square root of 9 is 3, but it's going to be 3i. But also remember, when you're taking square roots of a number, it's plus and minus, okay? So now I have two different equations. I have, let's actually put the x minus 2 on the other side. Let's flip this around. So I'm going to do x minus 2 equals positive 3i, and then x minus 2 equals negative 3i. Okay, so add 2 to both sides. And I get x equals 2 plus 3i, and x equals 2 minus 3i. So that would be the imaginary solutions. Okay, but really, once you see that, a negative and a square root, no real solution. That's all you really need. Okay, so let me show you quadratic formula, which is what some of you guys might try. Because you might try that x and it didn't work, and so you set up the quadratic formula like this. So you go through the steps, you find your a, b, and c, you plug it into the formula. Okay, so you plug in the -4, the 1, the 13, and the 1, and then you do negative times negative, so you get a positive. That would be 16. -4 times 1 times 13 is -52, and then you subtract those, and you get -36. Now, right there, as soon as you see a negative in a square root, you know right away, no real solution. Okay, so you're just like, well, there's no solution, basically. Now, if the question asks you for the imaginary solution, you can keep going. And you say, okay, it's a negative, and the square root of 36 is 6, but because it's negative, it's going to be 6i. Okay, and now I'm dividing both of these by 2, the 4 divided by 2, and then the 6 divided by 2. So then I get the same answer that I got when I did completing the square, 2 plus 3i and 2 minus 3i. Okay, so that's what you would end up with if you did the quadratic formula. Okay, so the last one's here. So I changed up the numbers a little bit. I think I got to change up a couple more here. Let me make a couple edits. All right, so this last few problems, we're going to be writing possible equations for the graphs below. All right, so first we got to identify the graphs, because if we don't know what the graphs are, the parent functions, then we can't even develop an equation. So now notice here, this looks kind of like the log function, but flipped. But I need you to remember that log functions, they usually don't go past this line, right? And we don't know if there's an asymptote. So I'm going to assume that this is an exponential function, okay? Because it comes down, it starts to get really close to 0. So that's usually a exponential that's kind of coming down. So the equation for exponentials is your a, which remember is your start value or your y-intercept, times the b value, which is the rate, okay, or rate of growth, raised to the x power. Okay, so to find that, we know the a value because that's the y-intercept, which is at 6. So as I start writing this out, I can write 6 here. I just don't know what this growth rate is. It goes from 6 down here to 1.2. By the way, your guys' graph is 1 and 1.5. That's a 1.5 if you can't read that. So I can't really tell you what the rate of change is here. So what I'm going to do is I'm going to use those numbers to solve for b. Okay, so what I'm going to do here is I'm going to take that 1 and 1.12, and I'm just going to plug it right into the function. So I'm going to plug in the y for 1.2 for y, and then plug in the 1 for b. So this ends up being b to the 1, which really is the same thing as just b. Okay, so now to solve for b, I'm going to divide by 6 on both sides. And that should give me my b value. So I'm going to use the Desmos calculator for that. So we're going to do 1.2 divided by 6. Now it gives me the decimal, but I'd like the fraction. So I'll click that button, it gives me 1/5. So that is the b value. So my b value is 1/5, which means my function is going to be 6 times the b value of 1/5 raised to the x. Okay? Now this one is a straight line, and we know straight lines are y equals mx plus b. So really what we have to find is the slope, what's the rise over run, and then the y-intercept, because you can see it doesn't give you the y-intercept here. It only gives you these 2 points. So what I'm going to do is I'm going to figure out the slope first. Remember that slope is your rise over your run. So starting, I'm going to figure out how far do I go up, or what's my rise, and then what's my run. Okay, so remember, these are y values, right? So right here, this is the y value of -4, and it goes up to the y value of 2. So if going from here to here, we're going from -4 to 2, which would be +6. Okay, and remember, your guys is different. That is a -3 and a -7. I know it's hard to read. And that is a +3 and a -3. Okay, so I know it's hard for you guys to see that. Okay, so I'm going to go up 6, and then here I'm going to change the x values. Okay, so going to the right. So I'm going from -5 to 5, and that will be +10. So that means my rise was 6, my run is 10, and then I can reduce that by dividing by 2. So I divide by 2, I get 3, divide by 2, I get 5. So there's my slope. Now I just need to find the b. All right, so to find the b, I'm going to set up the equation, 3/5x plus b. And I'm just like I did here, I'm going to plug in one of these points into the equation to find the b. So let's plug in this one, the 5, 2. So 2 goes for y, and I'm going to multiply the 5 here. Nice thing is that these 5s will cancel. Your equation will also do the same. I subtract 3 here. And so b equals -1. So my final equation is then 3/5x, that's the slope, and then I write in the b, -1. Okay? Now this one, I'm going to do this one on a separate piece of paper. So just so you guys can see what your numbers are, this is -0.5 and -6.25. Okay, just so you guys, if you can't see it. But what I'm going to do is I'm going to take another piece of paper, and I've created a new one. So mine's at, my vertex is at 2.5 and -2.25. It crosses the x-axis at 1 and 4. If you guys look here, yours guys crosses at 3, -3 and +2. Okay, so we're going to use all that information to figure out our equation. Now remember, with these, I'm going to write this up on the packet. This is a quadratic, so that means we're going to use the graphing form equation of a times x minus h squared. Remember, we've been using this a lot, plus k. All right, so we already have h and k. So that's these values here. So let me write that out over here. So I have y equals, I don't have a, but I have my h, so x minus 2.5 squared, plus the k, so minus 2.25. All right, the number I need to find is the a. So what I'm going to do is I'm going to take one of these points, I'm going to plug it into the equation, and then find my a value. So I can pick anything here. I can pick, just don't pick the vertex. Can't do that one. That won't work. I can pick this x-intercept, 1, 0, 4, 0. I think there's also another y-intercept at 0, 4. You guys have multiple points to choose from as well. Here, this x-intercept, this x-intercept, this y-intercept, you can kind of choose whatever you want. I am going to choose, let's choose the 4, 0. Doesn't matter. Okay, so we're going to use 4 and 0. So we're going to plug in the 0 for the y. The 4 goes into x, so 4 minus 2.5. You just got to work through the steps. I know that you see decimals and you freak out, but you can do it. All right, so now 4 minus 2.5, take out your calculator if you need it. No shame in that, but it is 1.5. Okay, now we need to square the 1.5. So that I will get a calculator for. Okay, so 1.5 squared. So that's 9 over 4. I'm going to go ahead and write the decimal. So 2.25. So 2.25a minus 2.25. All right, so now I'm going to add 2.25 to both sides, just like I would in any other equation. Now it's 2.25, and you guys can kind of see where this is going. Notice I have the same number, right? And so when I divide this 2.25 from both sides, it ends up being a equals 1. Okay, so that what that means then is that I don't really need to write anything for a, because if it's 1, this is basically my equation. Y equals x minus 2.5 squared minus 2.25. Okay, that's it. All right, so now let's do the next one, the circle. Okay, so now I remember with the circle, the graph and form equation is x minus h squared plus y minus k squared, and then equals r squared. All right, so what we need is we need to know the center and the radius. Okay, so I've already written the center here. It's at -1 and 2. Yours is at 1 and 4. And then I need the radius, which I just go from the middle and I go to one of the sides. So let's go up from the center to the top. So 1, 2, 3. So that r equals 3. All right, so let's just fill in the equation now. So x minus, well, if that's -1, that means I put +1. And then for y, if that's +2, I put -2. And now when I put this number, you got to remember the equation is actually r squared. So I take my r and I just square it. Okay, and that is it. And remember, you guys got to do your own problems. So make sure you guys are following yours.